Hey guys, welcome back. So in this video, I'm going to be doing AMC 10B 2021 Fall 13 and 14. Okay. Which overall are really not that hard problems. I actually found 13 to be pretty easy. It says a square with a side of length 3 is inscribed in an isosceles triangle with one side of the square along the base of the triangle. A square with side length 2 has two vertices on the other square and the other two on sides of the triangle as shown. What is the area of the triangle? Okay, so basically what it's telling us is that uh, it's telling us that this distance is 3 and this distance is 2. So or like, yeah, right. So these are squares. So this is 3, 3. This is 2, 2, right? Now, this is actually super easy. If you just work with similar triangles, it's like incredibly easy problem, which is why I think similar triangles are such a valuable thing to know, to practice, because using similar triangles can help you on so many of these problems. It can make a lot of these geometry problems a lot simpler. So if we know that this distance here to here is 2, right, from here to here, well, then we know this is like symmetric. So then we know that this distance here must be 1/2. And this distance here must also be 1/2, right? But if you think about it, this this triangle, right, this little right triangle here is similar to this right triangle here, right? So those two triangles are similar. And you can convince yourself because, like, this line is parallel to this line is parallel to this line, right? So therefore, like, this angle is equal to this angle, and then these angles are both 90. So then therefore the two triangles must be similar, right? So notice how let me just erase a little bit. Whoops, I didn't go too far. Notice how, like, this distance is 2, right? This distance here is 2, right? And this distance here is 1/2. Well, that's a 4-to-1 ratio, 1-to-4, right? It's a right. So that means that if this must also be in a 4-to-1 ratio. So 3 divided by 4 would be 3/4. Whoops, why is it? So this distance down here must be 3/4. This distance over here must be 3/4 because of symmetry. So therefore, the base of the triangle has distance 3 plus 3/4 plus 3/4, which is 3/2, right? 3 plus 3/2 would be what? 9/2, right? So we know the base of the triangle is 9/2, right? Now, if I draw this height here, right? If I draw this height here and I make this triangle is also similar to those other two, right? It's also a similar triangle, right? And again, same reasons, like this and this are parallel. This is a transversal. These must be equal. These are both 90. Therefore, the triangles are similar. So you can easily convince yourself that those three triangles are all similar, right? Now, notice how this little half distance down here is 1 because the whole distance is 2, right? And again, it's in a 1-to-4 ratio. So therefore, this distance must be 4, right? So the height of that triangle is 4. So do we now know the height of the entire big triangle? Well, this is 4, this is 2, and this is 3, right? 4 plus 2 plus 3 is 9, right? So the area of the triangle, 1/2 base times height, is 81/4, which reduces to 20 1/4. Whoops, that looks awful. 20 1/4, right? And 20 1/4 is choice letter B. So the answer for 13 is B. Right? And again, I thought that one's like pretty easy. If you just work with similar triangles, that's a really easy problem, especially for 13. Now, I will say 14 drove me mental. It drove me mental because I really, really, really overthought the problem, and I tried to do it in like I knew the thought process involved in this problem. Like I know what the trick is, but I just for some reason, like no matter how I did it, my answers were coming out like bigger than one, which doesn't work for a problem, or like either negative or bigger than one. So okay, it says Una rolls six standard six-sided dice simultaneously. Wow, that's a tongue twister. Six standard six-sided dice simultaneously, and calculates the product of the six numbers obtained. What is the probability that the product is divisible by 4? Okay, well, how would the product be divisible by 4? The product would be divisible by 4 in two situations. You either have two even numbers. Either one of them has to be a 4, at least one of the dice has to be a 4, or at least two of the dice need to be even but not 4, right? Because otherwise you're double counting situations. So two of the dice can be like a 2 or a 6, or at least one of the dice can be a 4. But it actually turns out that the easiest way to solve this problem is to do what's called complementary counting, which means like, what's the opposite, right? What's the probability that the product is not divisible by 4? So to not be divisible by 4, you have two possible cases, right? One in which basically all the numbers are odd, right? So the number's not even divisible by 2. Well, what's the probability that all 6 of the numbers are odd? Well, that would be 1 over 2 to the 6, because that's basically all odds, right? Okay. The other situation would be that the product is divisible by 2 but not by 4. In order for that to be the case, then exactly one of the dice needs to be either a 2 or a 6, and then the other 5 need to be odd. So exactly one of the dice needs to be either a 2 or a 6. So that would be 6 choose 1 to determine which of the 6 dice is a 2 or a 6, right? The probability of rolling a 2 or a 6 is 2 out of 6 or 1 out of 3. And then the other 5 need to be odd numbers because we don't want any 4s in there. And we also don't want any more 2s. We just want 1, 2, right, in the product, right? So now, if we add this together, this will give us the probability that the product is not divisible by 4. So what we need to do is we need to do 1 minus that, and that's going to give us our answer, right? So it's going to be 1 minus 1 over 2 to the 6. 2 to the 6 is 64, right? Plus, or actually, no, minus, right? 6 times 1/3 is 2. Oh, whoops, sorry, I made a mistake over here. This should be a 5. This was supposed to be a 5. So we get 2 times 1 over 2 to the 5, or 2 over 2 to the 5, right? Which is, so that's 1 minus 1 over 64 minus 4 over 64, right? Or 1 minus 5 over 64, which is 59 over 64, which is choice C. So yeah, it's not that hard, but I will tell you that I did a lot of work that led me nowhere. Because I tried to I tried to solve it by figuring out I tried to sort of instead of doing complementary, build the probability by saying what's the probability of getting at least 1 4 or at least 2 non-4 even, so 2 or 6, right? At least 2/6s. And then, but the problem is you would have to then subtract the overlap probabilities, which is really complicated to think about. And my answers just kept coming out really crazy. So it turns out that this is the best way to solve the problem. So definitely the most efficient way. Okay, all right, so that'll be it for this video. My next video, I will do 15 and 16. All right, so, all right, see you later.